good, but it's close enough. All right. Now remember, this is actually in this form, which is a simplified form of that, but we've stretched everything and flattened everything so you can see it blown up. Now, I can't fit the entire DNA on the board. So this thing is technically going much longer. I'm just showing you a portion of it. All right, so this is your DNA molecule. So what do I have right here?
Nucleotide?
Good, a nucleotide. And then here's another one. Here's another one, here's another one, here's another one, here's another one. So I have 2 strands of nucleotides twisted together helically. They're both twisted together. That's why I got a double helix. And they're held together in the center by hydrogen bonds. So these dotted line bonds, those are hydrogen bonds. Easily formed, easily broken, gives the molecule resiliency. If I spelled that correctly. These bonds here, the CPI bonds, and this bond here, those are covalent bonds. The covalent bonds are strong bonds sharing of electrons. These bonds will stay together when the hydrogen bonds break. So what's happening here? It's like a ladder. The side rungs of the ladder will always be intact, but the ladder can open up in the middle as if somebody cut the steps of the ladder and pulled the 2 sides of the ladder apart. And that's how DNA is replicated, in the middle. So what's going to happen is a whole series of enzymes are going to go to work in the cell for a bacterial cell right here at the nucleoid. This is where DNA replication happens. And the cell is going to open up its DNA, copy the inside strands, and close it up again. So, I'm just going to make a quick little model. Here's my DNA. And I'm going to call it SC, semi-conservative replication. I get that. My original DNA opened in the middle, and it actually opens from this end and from this end, and the 2 copies are made in the middle and meet in the middle. So it's going to copy from this end that way and from this end that way. Okay? You don't have to worry and get all hung up about that. You know, there's 3' and 5' ends of DNA, and there's a direction for the copying. And if you're copying in the forward direction, you're stitching forward. If you're copying the opposite direction, you have to back stitch. And when you back stitch, you make little pieces called Okazaki fragments, and then they have to be all put together properly. And then you have proofreading enzymes. And the proofreading enzymes go through and make sure everything was done correctly. And if it wasn't done correctly, you have other enzymes who will chop out the mistake and figure out the correct thing and put the correct thing in. So when DNA replication happens, it requires a lot of stuff. So we're going to call that our shopping list for DNA replication. It's so funny. So, the last 4 years, I shouldn't tell you political stuff, and you know what, the board of directors is coming